In this video, I want to demonstrate my project on modeling and analysis the attack in the complex networks. And my name is Wong Chun. My project code is F16. So let's have a brief understanding of this project. Is here. We can see that in this project, I'm using hybrid networks for the demonstration. As we can see here, the networks outside is the smaller network. We have less connectabilities or less neighbor nodes compared to the core network, which is the scale-free networks. Let's see the programs. Yeah. So for running the program, we can get this diagram. Here we can see that this network is not having much nodes here, but we can simply just adjust the global variables here, and then we can get more of the nodes and make it more likely to be the real world networks. Yeah, but in the reports, why I'm not using too much of the nodes, because I want to have optimized visualizations of the showing the DDoS attack of the networks. So here we can see that although we can use the zoom in function to take a closer look for some specific nodes, but you can see as we get more nodes here, the lines in the backgrounds will disturb our sight, and it's hard for us to do the analyze in this environment, and also is hard to see the whole diagram clearly, which just by our eyes we can difference that the blue dots is smaller network and red dot is scale-free network, just like the last photo. So that's why I'm not using that much of those in my uh, demonstration. Yeah. So also we can take a look on the others, like DDoS attack simulations. Let's pick one, like the DDoS attack, HTTP DDoS attack. So here we can see that it have a clear view for us to know what is happening in our network. For example, there's red dot represent the attacker, green dots represent the botnet. We can also change this label by, for example, the green dots, we are not using B1, B2. Maybe in a real world case, we can switch it to the IP cameras, and then the analyzers will clearly and fast to know what happened in the network. Or in others attack, they may not just be having the IP cameras, also the printer, and then we can have a quicker view for the analyzer and know what's happened in the network, and then to have a pop-ins or updating the network by, for example, update the printer driver, and then to avoid the company networks is violated by the DDoS attack. Yeah. So here we can also see that there's a note that this botnet send a high volume of the HTTP request to the target, which overwhelming the resources. Yes. Here we can take a look for the Facebook social network graph, which is based on the neural network. The data set is from the Stanford website, so it's also mentioned in my report. Where this one. So here we can see that it takes more time so when we get more nodes. I find that when the nodes is more than 1,000, then it's not time efficient uh, for um, the testing part. Yeah, but in real world analysis, this time is not quite dependable. Yeah. So here we can zoom in more here. Yeah, we can see that this part is a um, scale-free network here. Without the label, then we can tell because we can see that there's more connections, especially in these nodes. Yeah, you have a lot of connection. So it might be a core um, server of some or something else in the company network, which is critical to the whole system. Yeah, and the I've also used this network to simulate the DDoS attack, and then let's pick one. Let's pick the DNS amplification. So here I've reduced the nodes. I've only used the node 107, which I found that it have most it have the most connection to a lot of others nodes. Of course, here is not showing all of the other nodes that the node 107 is connected, but is enough for us to have a basic understanding of this algorithm, how it works. Yeah. So also I have to mention that in my earlier version, I have used the multiple page for demonstrating the DDoS attack flow, but I found that it's difficult for us to put all the data, all the photos or the screen cap to the report, and this because it will make the report very clumsy. So I put the all all of the information in one windows and then make it simple for demonstration. Uh, for real usage of this program, we can simply just copy this again by updating the for example, the nodes here, it may be one of the botnets and then one of the infected computer. And then in real world DDoS attack, it may have another jump to the other controlled computer or controlled network and to keep jumping and jumping till to the last target. Here we can see that it just jumped 2 times and then it go to the target. But in real world attack, it may not be that simple, but it's not affecting our algorithm because it's simply the same thing. Yeah, so for better visualization, that's the reason that's why I have decided to make the design like this. Yeah. So back to the topic. Here we can see that the blue dots here, they are the nodes that connect to the target. They appear here. Yeah, we can see that they simply just not doing anything. Yeah, but in real world, this kind of nodes is also important because they may not be infected in a company network, but we can also see that which part of which department of the company is not affected based on the uh, this visualization program. So back to the object part report. Yeah. So here we have a little sum up. So in this project, I have realistic modeling, which is a hybrid network using combining the scale-free and smaller network topology to mirror the real-world systems like social networks, which is the Facebook dataset from the Stanford website. And then we also have comprehensive attack simulations, which is based on the 2024 Q4 reports, Q4 DDoS report from Cloudflare. And then we have enhanced visualization. We can see that the plots are very clear with labeled nodes, which is, for example, A, B1 to B10, T for target. Of course, we can switch all those information to others like the device type or the IPs, but in my project, yeah, for clear views, I didn't use that. But the algorithm are the same, so I didn't really care about it. Yeah. And we can see we have adjustable network scale. For my home computer, I will be panic on if I have too many nodes for generating and have to wait it to generate the whole graph. So I simply just use a few nodes to represent the whole neural network. But in business use, this program can simply adjustable, yeah, for the network scale. And we are also using the real applications. For example, I'm targeting the node 107 in the Facebook dataset because it is the highest degree nodes I found. And also there's evidence for why I'm using this, yeah, here. So in my program, in the SYN flood attack model .py, we can see that the degree of target nodes 107 before attack, which is 1046 among 4039 nodes of the whole graph. So this node is the highest degree uh, nodes, and that's why I'm using it as my in my demonstration. But of course, I'm not showing all of the nodes here because it's hard for my 1080p screen to show all the nodes clearly without blurring. Yeah. Yeah. Also in the reports, when I make it smaller, we can see that it's already grouped as together, and we cannot see the lines properly. So back to the topic. Yeah, but also we have in this project, I've also found some limitation because in this program is lack of quantitative matrix, which is, for example, LCC, central T, or something like that. We have only basic statistic nodes and edge counts were available. This is because the data set is only contains the um, node and the edges. We can take a look the Facebook combined. Yeah, we can see that it just giving us the nodes number and then it connected nodes, and yeah, so not much I can do for implement the whole data set more clearly. Yeah. So this limitation is come from the data set, and then single run simulation. Yeah, this because it's hard to put, like, for example, in each type of attack, if I put 10 capture screen or 10 photos for that attack, and then this report will have a lot of pages. Yeah, but the algorithm, they are using the same algorithm to generate the graph. So I think it's not quite important for doing that much of repeated works. So yeah, this part I'm abandoning it. Yeah, for this reason, by this reason. And the simplified attack models, it is also because of I want to have optimized visualization in the screen, yeah, and also in the report capture picture. And then the network scale. The network scale is quite small in this report, but it can simply multiply and set to more than 10K of the nodes by simply switching the or changing the global variables. So in the future work, we may put more quantitative analysis and then dynamic simulations, for example, time varying traffic models to simulate the realistic packet flows. But in here, I have a very simple version of this because this is not dynamic, but the arrows here is also considered as the traffic flow. Yeah. So actually, at the beginning, I want to add a mail icon, and then it have a dynamic or animation that can floating between the lines. But I consider it as some fancy work or fancy UI, but it's not quite important for our core um, program, so I skip that. And also to make this more fancy, we can have multiple runs, optimize scalability by using the parallel processing or cloud computing to handle more nodes and edge to build up larger networks. And then high resolution visualization, we can simply use high resolution displays or vector graphic SVG, yeah, to avoid the blurring, yeah, for large scale network. And also the defense mechanism, for example, the IP filtering, rate limiting to analysis the attack. But in this case, I do find some PCAP file that introduce the real world, for example, DNS amplification attack. But for the same reason that I abandoned this future work in my project because it's hard to show all the wanted information in a very small graph. Yeah, So that's why I'm abandoned this option, but it's quite simple to add it to this program. You can simply just use something like importing the real data, the real data set. Same method like reading the text file or reading the file, and then to make it automatically to input uh, all the needed materials. For example, the device type, their IP, where they come from, and the timestamp, something like that. As and this is the end of my demonstration. Thank you.